Okay, so this is worksheet number 1 over the lymphatic system. So the first part in lymphatic system, it can also be known as immune system. It's called lymphatic system because of the lymph glands, but it's called the immune system because of the action, immunity. That's like the action. So typically, all of these are the function of lymph except for this transports nutrients to the tissue cells and removes waste. That's a function of the cardiovascular system. Lymph is like a thin kind of fluid so if you look at those pictures in your anatomy books, you look at a person, they have like the veins, which are blue, and then the arteries, which are red, and they have the green, and the green is like the lymph. So it kind of runs right next to arteries and veins and everything. So lymph, the fluid, absorbs lipids from the digestive system and transports them to the bloodstream. And what are those called? The lymphatic glands in your digestive. Yeah, you have lymph nodes, but they're also called, like within your intestine. So you have lymph nodes in your groin and in your abdomen, which actually, this is a little bit of a tangent, but some kids, when they get like an infection or they get like a viral illness, they start feeling abdominal pain because they're not only do their lymph nodes in their throat, swell up, their lymph nodes in their abdomen swell up too, and this causes the abdominal pain. So yeah, they're lymph nodes, but more specifically, the ones that actually are in the intestine and absorb fats from the small intestine, those are called lacteals. So it's just a special phrase, but yeah, you do have like lymph nodes and lacteals within your abdomen. Lymph also defends the body against diseases by defenses and permanent immunity. So you have defenses, you have your innate defenses like your skin, your mucosa, and we're going to go through innate or nonspecific immunity because there's 2 sections. There's innate, nonspecific, and then there's specific immunity, which you kind of is like the adaptation immunity. You kind of adapt. So there's stuff that you're born with, everyone is, and that's like your main defenses, like your skin. Everyone has mucosa, but then you have your specific immunity, which is specifically for certain diseases. So if you've been exposed to, like the flu, you have immunity from the flu after you get sick, while someone else may not have the flu, or who hasn't had the flu catches it because you guys have specific immunity defenses.
That's why you only catch it once.
Yeah, you only catch.
It's going around, you only get it one time.
You only get it once, yeah. Yeah, same thing with like chicken pox, I guess. You get the immunity to the chicken pox, you don't get it again. Someone else may not have that, so they may catch it later on. So your immunities are specific, they're different. So when we get into that, that's something to keep in mind. But yeah, you only catch it once. That's a good way to go about it. Lymph also transports interstitial fluid from the interstitial spaces to the bloodstream. So what is interstitial? What does that mean? Yeah. Interstitial means tissue. So it transports fluid from your interstitial tissue into your bloodstream, which is important because what happens if you have too much interstitial fluid or too much fluid? Swelling, edema, yeah. So your lymph kind of also helps transport it out. It takes it out of the interstitial, puts it in the bloodstream. Next question. Lymphatic system carries fluid from the bloodstream and into the interstitial spaces. This is false, just like what we went over. Lymphatic system carries excess fluid from interstitial spaces from your tissues and back to the bloodstream. So it kind of gets that out. Number 3 is going over just a little bit of a pathway. Lymph flows, the fluid, so in the heart, fluid flows from your heart through your arteries, through your veins, back to your heart. With lymph, it flows from your lymph capillaries, which are not the same thing as blood capillaries. It's different. And it goes to the subclavian veins in the thorax. So if you break down this word, subclavian, sub means under, and clavian is talking about your clavicle. So subclavian veins are here. And your thorax is like this whole portion of your body. What is true of lymph capillaries? I believe I want you to fill in each of these. No? No, maybe not. Okay. Oh, okay. So all of these ones in red are false. So the true of the lymphatic capillaries is this one, merge into larger lymph vessels. So all these other statements are false up here. This is the only true one. And what is in red is what is false about it. So for the first one, it says, thick walls provide for easy diffusion of tissue fluid. If you cross out thick, put thin walls, right? Because diffusion happens through thin walls. Number 2, the statement says closed-ended tubes with very small diameter. This is false. You want to make it, what did I put? Large diameter. So lymph has thin walls, large diameters. They're pretty open. They are not found in the CNS. If your lymph, there are 2 places your lymph fluid is not found. That's in your central nervous system, on your brain, your spinal cord, and also in the cornea of your eye. This is important because if we have lymph fluid in our CNS and spinal cord, you get an infection, you get inflammation, that'll damage your brain and everything. So we don't want that. Lastly, in case there's a question about the structure, lymphatic capillaries are simple squamous epithelium. So what is the difference between squamous and cuboidal?
Cuboidal is more than a protection.
Mm-hmm.
Squamous is for secretion, like also squamous.
And diffusion, yeah. So cuboidal is like for protection because they're cubed, they're thick, so that avoids it. Nothing can get through it. But we want our lymph, we want that fluid to move. We want that fluid to be transported. So it's simple squamous, and squamous is the flat. Simple meaning one layer, squamous meaning flat. If they were multiple layers, it would be stratified squamous, but it's not. It's simple squamous. It's kind of like in your, where else is it simple squamous?
What else?
Yeah, what else that we learned about? Easy diffusion.
The blood capillary is also.
Where is it?
About it, just like
Capillaries in the
Lungs, right?
in your lungs, around your alveoli. Yeah, simple squamous. We want that. So we don't want this. Unless it's in areas that we want protected. So, because then if it's not protected, then yeah. All right. I think I butchered, that pretty well. Okay, so this question was going over kind of what we covered before. This is false. Lymph nodes are found in the digestive system, and they absorb fats. This is false because they're not called lymph nodes. When they're inside your digestive system, within your intestine, they're called lacteals. These are in the villi of the small intestine and function to transport absorbed fats out of the digestive system and into the bloodstream. So just kind of keep that in mind. If you see the word lacteal, it's in the digestive system. So lymph vessels, like veins, contain semilunar valves to prevent backflow. So when we went over veins, right, we talked about valves to help transport blood up because why don't arteries have valves? Yeah, so your valves prevent blood flow from flowing back. But what about your arteries? Do your arteries have valves? No, they don't. No, because they have the heart, right? They have the heart to push it all through. But your veins have valves to prevent them from backflow, to prevent varicose veins, to prevent pooling of fluid. So with your veins, what is it that gets your vein, that gets the venous system running? So if your heart controls your arteries, what controls your veins? What controls that movement?
Pressure, right?
Yeah, pressure, muscular contractions. Kind of whenever you squeeze, it kind of, well, I don't have very much, but whenever you contract, it kind of squeezes that up little by little. So that's how it is with the veins. Same thing with the lymph. It's the exact same thing. So when I was younger, my grandpa used to always say, let's go for a walk and get our lymphatic system running. As a kid, I didn't even know what the lymphatic system was because he was wanting to get more immunity so he wouldn't get more sick. And what he was talking about was circulating this lymph fluid to clean out his system, you know? So a lot of the time you hear people who stay in bed all the time get really sick. It's because they're not circulating this fluid, so they get really sick. You know, it's not circulating. Well, it also is, there's also other things. Other systems are affected when you don't move too much. But yeah, we like to get that circulating with muscular movement. Two functions of lymph nodes. Well, they clean and filter lymph fluid. So your lymph fluid, so your lymph node is kind of like a node, is like a mini organ, and you have some under, what are these called? You have your sublingual, which are like in your tongue. You also have your palatine tonsils, which are in the back of your throat. So that's also lymph tissue, not necessarily lymph node. Let's see what else. You have lymph nodes in like your armpits. You have them in your throat. Yeah, like probably in this somewhere, yeah. I don't quite know. I just know like the main areas, because I know like when I get sick, mine inflame. So I'm like, wherever it hurts, that's where they are. So yeah. So you have some in your groin too, in your abdomen. Yeah. So, and they're all over. So they basically work as little filters, and your lymph fluid flows through lymphatic capillaries. So that's kind of what it does. Kind of. Yeah. So it's a lymph node. Another thing that lymph nodes do is they produce and distribute lymphocytes. And what's a lymphocyte?
The white blood cell
It's a type of, so yeah, so you have your white blood cells.
for immunity.
Yeah, so you have your white blood cells, which are for immunity. And you have different groups, right? We talked about this when we went over blood. You have your, what's one that?
Monocyte,
Yeah, you have a monocyte. What's another one?
lymphocyte,
Lymphocyte, yeah. What's another one?
neutrophil,
Yep.
eosinophil,
Eosinophils,
yeah, basophil.
basophil.
Yeah. I'm familiar with all this stuff.
Okay, yeah, so your lymphocytes, though, is what we're going to be focusing on for the immune system. So even though all these are here, which we learned about in blood, your monocytes, your neutrophils, your eosinophils, your basophils, lymphocytes are the ones we're going to be focusing on. And what is a lymphocyte that we know of? What are they also known as? There are two categories.
They involve the
That's a phagocyte. That's what your mom. B cells and T cells.
oh yeah,
Yeah, I wasn't trying to trick you. Yeah, so there's two categories we'll be learning about, B cells and T cells. Those are your lymphocytes. So your white blood cells are these different categories. All these other ones come from, I believe, your bone marrow. But your B cells and your T cells specifically come from your lymph nodes. And another thing too, there's a graph that we're going to do too, is these monocytes, neutrophils, eosinophils, basophils, those will all be in your innate, natural, normal immunity. Everyone has it. Non-specific immunity, like your skin, your mucosa membranes, everyone has these. But your lymphocytes, your B cells and your T cells are part of your specific immunity. So there's different there's two different worksheets on these. Just keep that, going forward. So let's see. Number 8, the subclavian trunk drains lymph from the legs, lower abdomen walls, and pelvic organs. This is false. The lumbar, so your subclavian, again, is up here, under your clavicle, subclavian, sub meaning under. And so your subclavian drains from your arms and upper part of your trunk. Your lumbar, though, which is down here, this is the lumbar, like the lumbar portion of your spine. That is what drains the abdominal walls, pelvic organs, and the legs. So just when you're going through, looking at your graphs, looking at your PowerPoints and everything, just know, what are some other trunks? What do they drain into? So. let's see, so number 9, the lymphatic and I really don't like doing this anatomy. It's just like, ugh, it's so mundane. Okay. The lymphatic collecting ducts are the largest lymph vessels. This is true. So if you see lymphatic collecting ducts, these are big. So like your veins and your arteries are big and your capillaries are small. Your lymphatic capillaries are small and your lymphatic collecting ducts are big. You know, they're the biggest things. So that's true. 2 main collection ducts are your thoracic duct and your right lymphatic duct. And I'm going to scroll down a little bit so we can review these. So your thoracic, okay, let's get that there. Your thoracic duct is due to the cisternae chili, I don't know. I think I knew this when I made this, but I can't pronounce it now. Yeah, it's there. This consists of the right and left lumbar trunk and the intestinal trunk. So as you can see, you have your thoracic duct, which is the biggest thing in your body, really, and you have your right lymphatic duct. And the main takeaway is your right lymphatic duct only is in your right, it empties, it drains into your right subclavian vein, while your thoracic duct is what drains into your left subclavian vein. So you may see something like, what drains into your left subclavian vein? And Janet may put like a question up there that says left lymphatic duct, and it's wrong because it's the thoracic. The thoracic is what gets the rest of your body. The right only gets, like, I believe, your arm and your head. But the thoracic duct is like the majority of it, but it drains into your left. Well, I guess this is my left. I'm thinking about your left and my left, so. So a good way to remember this, thoracic duct, from the legs to the left side of the body. Legs to left side, L to L. That is your thoracic duct. Your right subclavian vein is just right side of the body. That's it.
Kind of weird.
Yeah.
Usually everything's symmetrical.
It's not symmetrical. So she may put like left lymphatic duct, and there's no such thing as a left lymphatic duct. It's the thoracic. So I can see her. She's tricky. But yeah, no, that is true. It is typically symmetrical. So, so this is the fun part. Okay, we get to talk about blood plasma. And what is blood plasma?
The fluid.
Yeah.
Fluid portion of the blood.
Yeah, fluid portion. So just the fluid. So you have your plasma. You then have, what does it say up here? Your tissue fluid. And then lymph. Yeah. So, or you're also known as, so if it's tissue, it's also known as what? Interstitial. Mm-hmm. Interstitial fluid. And then it goes into lymph. So this is how the fluid, and then with the lymph, it then goes up those collecting ducts and empties into your subclavian vein, your subclavian veins, and then the fluid circulates. So let's see. So blood plasma becomes tissue fluid, and tissue fluid becomes lymph. So what is the difference between each of these things? What does plasma have that tissue fluid or interstitial fluid doesn't have? So it has fluid, right? It also has,
Hormones, right?
it has your hormones, it has your electrolytes. It also has your formed elements, your red blood cells, also your white blood cells. But the big thing about plasma, which is all true, all of that is true, but the big thing that plasma has that lymph doesn't is plasma proteins. And in a worksheet, I'm going to pull up really fast. We went over plasma proteins in the cardiovascular system. Where is it? Cardiovascular. Oh dear, which one was it? Please, number 4. Please be this one. Yeah, yes. So remember we had this chart, right? We talked about hydrostatic pressure and osmotic pressure. Okay, hydrostatic pressure is the pressure from the heart pushing fluid out of your right, out of the bloodstream into the tissues. That's what that's showing right there. And then you have your osmotic pressure, which pulls fluid, which is like magnets, right? The solutes are like magnets, and they pull the water out of the tissues and into the plasma. The thing that controls the osmotic pressure is your plasma proteins, okay? And your plasma proteins are your fibrinogen, your albumin, and your globulin. And basically, yeah, so that's all you need to know. I'm not going to go into that. But you don't need to know those for sure, but just know plasma proteins. They're not your red blood cells. They're not your white blood cells. Plasma proteins are just proteins in your bloodstream that have osmotic pressure. Okay, just kind of know that. But they're the ones. So the big difference between plasma and tissues, as you can see in this picture, the only thing that is moving is the fluid. So the big difference between plasma and tissue fluid, or interstitial fluid, is just fluid. There's no plasma proteins. The proteins don't carry. The proteins stay within the bloodstream, which we need because we need that fluid circulating to regulate blood pressure. And once we get into the urinary system, this will make sense. So, but does that make sense for where it's coming from? Okay. So that's that.
The difference between interstitial and lymph is just the location, right?
Location, exactly. So it's still fluid. So you'll see like a question. I know one that I remember one from a quiz I got wrong. Chemically similar. Tissue fluid and lymphatic fluid is fluid and fluid, okay? These are chemically the same. Chemically, this fluid is the same fluid. The only difference is the location. So when it's in your tissues, when it's in your, let's say your, I don't know, what's a tissue? Skin, yeah. Okay, there we go. So when it's in your skin, it's called interstitial fluid because it's in your tissue. When it's in your lymphatic system, or your lymph node, or your lymph capillaries, it's called lymphatic fluid. So that's that. So just know the big takeaway is plasma proteins and these two, the only difference between the name is just the location. So, but the fluid is the same. So number 12 ties into this. Blood plasma has large plasma proteins in it. Tissue fluid has no plasma proteins. So as you can see, plasma proteins, none. Yeah, we don't want plasma proteins in our yeah, just stay in there. So this is kind of like going through it again. Blood plasma becomes tissue fluid when it leaves the blood capillary to deliver oxygen, leaving large plasma proteins in the blood capillary. So tissue fluid, yeah, we just went over that. So from that last one, we were talking about the osmotic pressure is kind of like the plasma proteins are like magnets. They pull fluid into it. That's osmotic pressure. When the plasma proteins within your bloodstream takes fluid from your tissue, which there is a little bit back and forth, but the majority of it flows like this. The majority of fluid flows like this in your body from your plasma to your lymph. But some of it kind of circulates back, it's how your body works. So osmotic pressure is the maintenance in blood capillaries. Osmotic pressure maintenance in blood capillaries is the reason why plasma proteins do not leave the bloodstream. Our plasma proteins cannot leave the bloodstream because if they do, our cardiovascular system has no way of regulating blood pressure or blood volume within your bloodstream. So just know osmotic pressure. So, lymph and tissue fluid are chemically unalike. Well, as you can tell, we said earlier, they're chemically identical. The only difference is the location of the fluid. I guess. There's no spell check. I guess chemically unique. They're chemically different is what, maybe different, yeah. Oh, no, it's fine. No, they're unkind. You know, they're unalike. We don't like them. Maybe chemically different would have been better, but yeah, but they're actually identical. I just wanted, I don't know, throw a hard word in there. A word that didn't exist. Okay, lymph fluid prevents edema, and edema is known as an excess accumulation of fluid in your skin. So this is why some people get like swelling, and a lot of, and question, what condition leads to a lot of edema? I mean, there's many conditions, but which one is, if a certain organ is damaged, which one is it that causes a lot of edema to happen? Close? No. No.
I was going to say the heart, CHF or COPD.
It could be CHF and CP. That's not the one I'm looking for. It produces plasma proteins. This organ's really important for liver. Yeah. So if someone has like cirrhosis or hepatitis, their liver isn't functioning well, they're not producing plasma proteins. If you don't produce plasma proteins, fluid can't leave, can't flow properly. And if it can't flow properly, then you have edema buildup. So just know that, future-wise, you probably won't know that for the exam, but that's why plasma proteins are so important. So fluid, so this is going back to, so I'll let you write these two statements down. Fluid leaves at the arterial end of the capillary because there is more hydrostatic pressure than osmotic pressure. And then fluid enters at the venous end of the capillary because there's more osmotic pressure than hydrostatic pressure. And this is due to a higher concentration of proteins in the venous end. Okay? When you get that written down, I'm going to flip back to that picture that we had. Got it? Okay, I'm going to go back to that picture of the cardiovascular. Oh dear, no. Go away. So looking at that picture, what was the first statement?
Fluid leaves the arterial end of the capillary.
Mm-hmm. That's what this is, these fat arrows. Fluid is leaving because of what?
Because there's hydrostatic pressure.
Hydrostatic pressure from the heart, okay? What is that the end of it, that first one?
The first one, yeah.
What's about the second one?
Fluid enters the venous, at the venous end of the capillary.
Venous end, right?
Because there's more osmotic pressure.
From the plasma proteins. Yep. Is that the end of it? Okay. So does that kind of make sense, putting that into words? So if you see venous end or arterial end, it's talking about in your blood system. Your cardiovascular, more precisely. And I put a rationale, which we already went out. The cardiovascular system uses the heart to pump blood. The lymphatic system uses muscular activity to pump blood, to pump lymph, And this is why lymph flow is higher during physical exercise. So it's kind of like when I went walking with my grandpa. He's like, come on, let's go walking and get our lymphatic system going. It's like, what are you talking about? So.
Is he a physician?
No, my grandma passed away of ALS. So ever since she got sick, he's been looking into the body, and he's really smart though. But it wasn't until so contracting skeletal muscles compresses lymphatic vessels, moving lymph, especially in the legs. We want that moving. Another thing too is respiratory pressure in the thorax and high pressure in the abdomen, so breathing in general, and you'll have that. I'll give this to you so you'll have it. But breathing also causes lymph to flow. And then smooth muscle. Smooth muscle also kind of contracts every once in a while to also aid in the flow of lymph. So that's that, and this concludes the first worksheet. So do you have any questions about? Okay.